Sphinx is really, really cool software. I actually did cut a bunch of stuff out of this right before I came over here because I realized there was no way I could do all of the features justice. So we're just going to cover the basics and hopefully it'll be interesting. And you can go figure out how to add it to whatever you're working on your own time. And that way we won't try and cram too much in here. So Sphinx, it's a search engine and a content indexer. And those, you would think that those are the same thing, I guess. But Sphinx calls them very separate things. They're separate command line tools. When you install Sphinx, there's two different programs it comes with. The indexer is totally separate from the search engine. Obviously, they know how to talk to each other. The search engine is actually a service that listens on a TCP port on a server, on your laptop, however you want to do it. The indexer actually just talks to the files that server is reading. The indexer doesn't stay running, so that's more like a cron tab style task that you would do. SphinxSearch.com, it's got extensive documentation, lots of blog posts on how to do different things. I will tell you that it's a little bit Apache style documentation where it's not in sans serif font and it's a little dense sometimes, but the information's all there. So if you're on Linux, apt-get, yum, etc., Homebrew on Mac has a great build of it. Windows.
Install Linux.
Yeah.
Yes.
They do have binaries for Windows. Unlike some of the other things out there that are kind of like this, these cool little packages you can get a hold of, they do have 32 and 64 Windows binaries. I've never tried them. I don't know if they're any good. Sphinx is in pretty much any package manager you want to get a hold of. As usual, Red Hat is way behind on the version. And even Debian is kind of behind on the version. This doesn't have many dependencies, so you could we actually in production compile it from source. And that's one of the few things we compile from source in production because the new versions are significantly better. Each major one that they put out is way better than the older ones. Let's see. So in order to use Sphinx, you need data in MySQL, Postgres, or alternatively XML files. A lot of people are taking Mongo documents and kind of figuring out how to get them into Sphinx to index them. And there's a couple ways to do it, but generally people are kind of dumping these Mongo documents out to XML files to have Sphinx index them, which isn't really as terrible as it sounds. I've never used it with Postgres personally, but I know that it works. Also worth noting that you actually need, if you're compiling it from source, or if you're compiling it on Mac with Homebrew, it actually compiles it. It is going to require these things. To make Sphinx talk to MySQL, it does need to compile with MySQL's headers. So it does need MySQL installed on whatever server you're going to build it on. Same with Postgres. I think it needs libxml if you want to do that. So you can talk to it from PHP very easily. There's a PECL extension that's pretty good. That does mean that you need root access on whatever server you're running it on because it's going to have to go download the source code for that extension, compile it, and change your php.ini. If you don't want to do that, there's a native PHP client that works really well. I don't suggest you look at the source code because it's like half PHP 5, half PHP 4, kind of a Frankenstein disaster. But it does all the things that you want. And the API is fine, it's easy to use, and you can just run this wherever. It's available on Composer, you can go find it on Packagist if you want to just pull it in that way. This is what we use at offers.com in production, we use the native PHP client. I don't remember why, I think we had some servers that had the extension and some servers that we were using the extension in production and the PHP client in development or something along those lines, and they're the same class name. So if you try and load them both up, everything goes to hell. The Sphinx client has no care for like, don't try and load myself if the extension's installed, so pick one or the other. So how do you do this? So first of all, data in the database, that's pretty important. You basically end up writing SQL queries that define what Sphinx will index. So it's basically a select statement, and I'm going to show you that. We're going to write one in just a minute. That will tell you what Sphinx should go look at for its indexes, and that's the things that you select are the things that it will index. So you run the indexer, Running the indexer is going to generate files on a folder somewhere on a server. Those indexes are then read by a program called searchd. Searchd is the thing that runs, and that's what PHP is actually talking to on a TCP/IP connection is searchd. So from there on, got your search engine up, it's searching things, people are using it, everybody's happy. New data gets into your database. At that point, you need to run the indexer again. Most people do this on like half-an-hour intervals or 5-minute intervals or daily. However often your stuff is changing, you run the indexer. Once you have searchd running, it can go in, the indexer knows how to go in and gracefully slide new indexes in instead of the old ones so that you don't have to like stop searchd and start it up again. It's pretty seamless as far as rotating those indexes in. Unlike if you've ever tried to rotate indexes in Lucene, it's terrible. This just works. And then you basically just do that over and over again. So you just need some sort of plan of how often is my data changing, how much do I care, how much my search engine has access to the latest and greatest data. It doesn't take long to index most things, but I wouldn't recommend you be like, oh, every 5 minutes we need to reindex the entire thing. Probably not.
How often do you run it?
Half an hour, I think. Could be an hour. Something along those lines. And that, wait, where did my video go? No. And that's probably excessive. We actually, side note, we actually get more of our searches from the autocomplete dropdown, which doesn't use the search engine. Very few people actually aren't satisfied with the autocomplete and then decide to go actually hit enter. But if they do, it's here for them. So index queries. One of the couple things, Sphinx has some rules. No matter what you're indexing, however you want to do it, every row that comes back in that result set has to have a unique ID, and it's got to be unique even if you're joining on multiple tables, however that works for you for your particular data set. It's got to be unique across the entire result set. That is usually seems like it's pretty obvious, but it actually can be difficult sometimes to come up with a unique ID, especially if you're pulling in some join tables and stuff where they may not have an auto increment primary key. It's really best to have an auto increment primary key as the unique ID. You can start mashing other things together, but that will end in tears 6 months later when you're like, oh shit, now we've got to do the whole thing over again because we hadn't thought about this. Auto increment's best. Also, the ID, you don't get to tell it what field it is. It has to be the first field in the select query. That's just a rule. So no matter what you write, whatever comes first in the result set out of MySQL or Postgres or whatever, that's the thing. It must be unique. Also, I'm going to show you, there's the Sphinx configuration file, which is where we write these things, assumes that you're going to write the SQL query on one line. You can kind of backslash it and make separate lines out of it, but the formatting is a little weird. It has, equals and curly brackets and everything for this config file, but no semicolons. So things you basically have to like escape out like you would on a bash command line, all of the different lines in your SQL query. Just good to know. Also, there's a flag. Basically by default, even today, even on a 64-bit machine, Sphinx is not looking at integers as 64-bit. So if you have big numbers that you're going to use for IDs, you have to pass this flag manually. We found actually that the Ubuntu 12.04 server does not ship, like the package doesn't have N64 compiled into it, which pretty much means it's useless, which is why we compile it from source. You get really nasty queries. When you start having really well normalized database schemas and all of your contents and all these great foreign key relationships, and then you realize you need to index on little bits of pieces of that data, and you want to pull all that together for the search engine, you have to pull that all into one massive query. And that can be interesting sometimes. It can be a lot of joins, and you end up with a select statement with like 70 columns in it. But that's okay. That's kind of expected, and that's how this works. Questions so far? All right. I think that's the last slide there. Let's switch back over to mirrored.
What is the motivation to use this over, let's say, MySQL's index?
It's faster. So MySQL has full text indexing in columns, but what you end up with is it's a full text index on a column. So if you have a column that's got like, if it's a blog, this probably MySQL's indexing can actually work pretty well because it's the content column in your posts table. For us, we have relevant content to a user when they want to search in probably half a dozen or more different fields and different tables. We have the name, we have the name and relation, we have the company name, we have user comments that may want to come up that all we want to index tied to an offer. And this allows us to index all of that content as it relates to an offer very easily, because all we have to be able to do is write a SQL query. Doing something like that with Solar or Lucene would also work. This is so much easier. It's not quite as powerful as Solar, but it's just so easy to get going compared to that there's no reason not to start here. Also, not everyone has access to the MySQL full text indexing on whatever server they're running on. This is a little bit easier to get a hold of.
What was the performance difference between Sphinx and Solar? Is it similar, comparable?
For us, Sphinx is faster. Not a lot faster, but it's also not written in Java. So we don't need a JDK on the server, and we don't need, Solar is hard. Solar is really hard learning curve, especially just like trying to get the first Solar server running. This will pretty much run out of the box with like 5 lines of configuration.
Solar shits the bed when you try to search while it's indexing too.
Yes, it does.
Yes.
This does not. All right, so let me pull up. So this guy up here this search box is powered by, that's going to be a bad mistake. So this page entirely is powered by Sphinx. So what we do is all of this content is indexed. Kind of hard to see on this TV. Go to a search box where I can filter this down and kind of refine my results. Also, all of this filtering here, these price filters, all of the facets that are in here, all of this kind of Amazon or Newegg style stuff, that's all powered by Sphinx, so there's no database queries that go on to power that. So you're actually able to index facets of information in addition to full text and filter on those things. And the important part, and I'm not going to show you how to do it, but just know that it's possible. The important part is if you have requirements that mean you need to get these numbers back, as far as I start adding filters to this search, and I want to know the possible counts of all of my next choices that are available still, Sphinx can bring that back in 30 milliseconds. It would be probably 30 MySQL queries for us to go execute and find all the different combinations of what's available next based on what I've chosen so far. It's extremely powerful for faceted search. I'm going to show you how to add facets, but the code to actually build all of the navigation for this was just way too complicated to show here. There's lots of articles on it out there, but the cool thing is that you can do it, and it's way, way, way less code. The whole back end to do all this filtering is like 300 lines of code. We would have had 300 lines of SQL, I'm pretty sure, if we were trying to write the database queries to power all of it. Okay, so got an empty folder here, so I'm just I need to make my font bigger. I'll read that. That's probably a little much.
9,000.
So I'm going to start with Composer. I'm just going to go ahead and grab this library that we use. I believe it is. So yeah, I'm going to use the PHP native client to do this. And I'm going to go here and create myself a sphinx.conf. So one thing that's interesting, when you think of installing this on a server, unlike a database server, where you would have like your MySQL configuration file is in Etsy somewhere and it's on the server. That's great. We keep the Sphinx configuration file in source control because it's not really a system level service, and also you're going to have to actually write SQL inside this configuration file. So it kind of doesn't really make sense to have it just live in the background of the server somewhere. You're probably going to want it to live with your application. And Sphinx, it's kind of designed to just you start up searchd and tell it what config file to use, and it's ready to go. So I'm going to copy this. Happen to have one of these already ready. So Sphinx, we need to tell it a couple things. We need to tell it what type of database we're using. This is just talking to my local host. Basically, we have sources in Sphinx. Sources are going to be a SQL query that provides content to the indexer, and then we can define multiple indexes within the same file. So you might have one for blog posts, you might have one for users, because sometimes you don't want to index every piece of content you have in the same search. Sometimes you do. So we have like 3 or 4 different ones depending on what page and what kind of feature we're powering. So can you see the equal? Yeah, you do. So basically you've got user host name, password, database name. These are pretty standard things. I'm actually going to index my copy of offers.com's offers as an example. So let's talk at an index. So this is kind of like the bare minimum. I need to give it an index, which basically is I tell it what index, where to pull the index from. My source is offers. I give it a path, which is where on disk do I want it to write the index files. And morphology is really probably you just want to use stem_en unless you're localizing into Russian, and then there's some other choices. Some of the other languages that aren't Western, there's better choices, but stem_en basically means do the best you can to know that business and busy and a handful of other things kind of all sound the same and probably mean the same thing. Ran, run, runs. It stems those all back to run, and then it'll know it'll do better searching that way. I've never had a need to do anything but that one, but you have to pass it in there. And then kind of searchd block down there is basically just telling it where to, when searchd runs, where does it write its pin file to. I've never encountered a place where searchd is started with service or something like that in an init script on a server. We always just, there's a script that just starts it up with searchd, passes the config file over. When I restart this on my laptop, it just kill all searchd. That's pretty much the end of it. And then start it back up again. So the sources would be pretty much the same across multiple things. What we do is the indexes we use for environments. So we might have a production index, a development index, and we might write those different paths. So like development might know on my laptop where it should write the files out to, and that might be different than production. And also, you can do different sources if you have different database credentials between production, development, that kind of stuff. So you can kind of support application environments just like you can inside a PHP framework as well.
Does it default to the MySQLi extension?
This?
Yeah.
This is using libMySQL, so it's actually talking to MySQL over the C.
Well, no, but the MySQL extension has been deprecated in core.
This is Sphinx config, it's not, this is not PHP code.
Okay, this isn't interacting with PHP then.
Correct.
Okay.
This is totally, so MySQL means use libMySQL client.
Okay.
Your other choices there are Postgres and XML. Okay. So the important part here is this SQL query, and you can see I've already started with backslashes because I'm trying to do multiple lines here and keep this readable. So offer ID is what my primary key is called. So we have that's going to be the globally unique thing that Sphinx is going to look at to determine the unique, because building documents and they all have to have this ID. So we'll also pull in the name, we'll pull in the company name, and let's see, what else should we do? What do we do for now? So basically so far I'm just writing SQL. This is how I join these two tables together. And that's kind of that. Should be enough for us to run the indexer.
You have to put an S
Did I miss
on
one?
your select.
Do I have to put an S on the second call? Yes, I do.
Right there.
This makes sense so far. So basically what we're doing is we're telling Sphinx where to go get its content when we index it.
What's your root password?
There's, luckily there's not one. It's just local. And I actually had to go redact because I do have a password. For
Heartbleed.
The other user, yes. So let's make this font a little bigger as well. Okay, so in my Sphinx directory here, I change this to be some other theme.
I can see it okay.
Yeah?
Yeah.
All right, well, let's just see if this works. So I'm going to run indexer, and that's the name of the indexer. It's indexer. So you tell it where your sphinx.conf is, and then you need to tell it the name of the index, which mine's called offer index. Let's see if this goes. Nope. Ah, great point. You can see also now that these are in black and not green, and what this is because this expects all this to be on one line, and I did not put backslashes in here to fix that. Just like I said would happen. Also, Sphinx doesn't like if you don't make it the folder where the indexes are going to go. It won't create the folder on the fly. So basically you can see it's going to go do this indexing. It's telling me I don't have any attributes. I'm going to talk about attributes in just a second. It's telling me all the documents it indexed. It indexed 102,000 documents. None of this is particularly interesting at all. But the point is it will now have written into my indexes folder all of these files. They're all important. So all of those guys are the different various ways that Sphinx is splitting these things up. There's even more when the server is running. And so you need basically some disk space for these. They don't take up a ton of disk space, but it is an index, so there is some overhead to it. So let's go write some PHP code to talk to this. How many of you guys are using Composer regularly? If you're not, you really should be. That's kind of Composer 101, is you need that at the top of the file. Sphinx client equals new, Sphinx client, great. So, PHP Storm doesn't really do great at auto-completing this because it's not PHP 5 code, and they haven't invested a whole lot of time and money making their autocomplete great for PHP 4. It's okay though, it works. The server is localhost, and I believe it's 9312. Let's do just that to start with. Tab. So everything's good so far because there are no error messages. So now we actually need to start up Sphinx, which is as simple as doing search D in this folder right here. So search D found there's a sphinx.conf in my directory, and it tells you, hey, I'm listening on 9312, everything's great. And it's telling you right now that it found my index called offer index. So if you have multiple indexes in there, you can tell it which ones to look at on the command line, or you can just start it up and it will read that config file and just make them all available. It's going to default to this one, so I'm not actually going to specify it in PHP code, but if there's more than one of them, when you create the Sphinx client, you need to tell it which index you want to search on. So we're good there. Let's see. Okay, so we're gonna come up here and we're gonna say Sphinx client query laptops. That's pretty much the bare bones code you can actually get results back with. And we'll go ahead and say print our results. Let's just see what happens. So you can see that it's got stuff back. It has an array of results here. You can see error is null. There is like Sphinx get last error, which is similar to if you're using MySQL or MySQLi, you want to get the last error message off the server. Pretty much a common pattern is to put this in some sort of try-catch block, and the catch is always just going to like either log last error from Sphinx or spit it out, so you can see like if you got no results back, is it because there are no results, or is it because the server sent you back an exception that you need to deal with? Interestingly enough, you can see that I've got stuff here in this array. Unfortunately, it doesn't seem very useful. These numbers right here are the ID numbers. That's the global unique column. So it's gone and searched my content, and it's found me what it claims are 417 results for this. However, you can see the data I'm getting back here, and it's really great. You found 417 results. What are they? We have to actually go tell Sphinx what we care about. Any questions so far? Yeah.
So on the SQL query results, can you do an object instead of an array?
I believe yes. I believe there's a thing that says Sphinx client arrow no array result or something along those lines, and it will give you back an object instead.
Just force an object.
Yeah. You can also JSON encode and decode it, and it will come back as an object as well, if you really wanted to do that. So we've got results. So now we need to talk about attributes and fields. So Sphinx actually gave me an error message up here, right about here, where it says their attribute count is 0, which basically means that, great, you indexed all these documents and you're going to get nothing back. It told us that, we just didn't know what it meant. So attributes are important. Attributes are things you can sort by, and attributes are things that you get back in the document. So if you work with any other document system, it's basically what data do you actually want to see when you get these documents back. It's doing its full text indexing based on offer name and company name, but right now when you actually get it back, it doesn't keep those in a original non-sliced up way that it can actually hand back to you. We have to tell it which ones we want back. So we can do this. this is also going to be a problem. If you have duplicates like that, just like in a PHP array, you're going to want to alias those columns so that you can get at them, both in the Sphinx configuration and also in the array that comes back, because by default it's an associative array and it's just going to step on them just like MySQL results will. So let's say we want an attribute, it's a string, that's how you type it, SQL attribute string. Let's make sure that's correct. It is offer, SQL enter string company. We come back here, it's the same. Hasn't been fixed. Why hasn't it been fixed? Any guesses?
And rebuild the index.
You gotta rebuild the
index
index.
again, right?
Gotta rebuild the index. So, same command, indexer, tell it the config file, tell it what index. However, search D is running right now. So if we just hit enter, it's gonna give us an error. It's gonna say, hey, search D is running, it's got locks on all these files, we can't do this. However, there's this nice thing, -- rotate, which is already suggested for us. And rotate will actually let it slide those in here. Now you can see that this has actually failed again. And this is what I wanted to show you. There's a really fine balance between having attributes and having things that are indexable. If you make it an attribute, it is not indexed. And that's actually on purpose. Because there's lots of things that make no sense to index, but they're great for sorting and filtering. Things where you have a tiny int 1 column where it's 1 or 0, or you have a price, or you have something that you would want to order by, but it's numbers, and it would make no sense whatsoever to index it as part of the search. Those are attributes. If you actually want it to be usable, field is what you want. Field means it is searchable and it's an attribute. But you want to balance this because field means, if you make it a field, that also means it's going to be searchable. Maybe you want that, maybe you don't. Also, you can balance the size of the files that this thing generates based on this sort of thing. If you have millions and millions of rows, making them all fields means that they'll all be indexed, so your indexes grow in size. That's fine, that's what we want. But if you make them fields, it also has to store an original copy of that text as well, because it has to be able to hand it back to you. So if you're talking about a 100 gigabyte database, you could easily make another 100 gigabytes worth of data if you get overboard on this thing. And now you've got a whole copy of it. A lot of times what makes more sense, depending on your application, is don't do this. In fact, we use it a lot of times. Go ahead and have this bring back the results that it wants, and we actually will then go look up the IDs out of the database and say, hey, we realize that Sphinx has now said, these are the 25 offers that match your search, and I'll go say, MySQL, give me select star from offers where offer ID in and list those things out. Because in fact, there's a lot of stuff that we don't index at all in here that we need to show an offer on the website. And so a lot of times we use Sphinx to get the list of things back and then go grab them in bulk with our ORM out of the database. That just totally depends on how complex your system is. For something like a search results page, Google style, where you've got like a name and a snippet and maybe a date, this is going to be totally fine. So let's try indexing this again. And you can see what it actually did, rotating index, it sent sig hub to search D, which is basically like Apache control restart, right? It copied the indexes into temp files, and it restarted search D gracefully and slid those new indexes into place. We can actually see, there's a couple more files in here when search D is running. So let's go refresh here. And you can see now in my attributes array there, I've got some offers. I've got some offer strings, I've got some company strings, and so now I have something I could actually spit out on the page if I wanted to. So we're getting close. This is sorted by default kind of on Sphinx's relevance as far as like how important it thinks it is. You can actually get in there and like boost. You can say like the offer name is more important than the company name, and you can give those weights. We're not going to mess with any of that, but you can tune it pretty well. Not as well as you can tune Solar, but you can tune it pretty well to kind of give things more weight than others when it does the index building. But so I've got some results here. It defaults to 20 results, unless you tell it otherwise. So I didn't write any code. There's 417 results that it found, but it only gave me 20 back. This feature right here, when you start really utilizing this, that's what makes that faceted navigation work really well, because it can tell you not only how many did you pull back, but how many possible results were there. And when you start really banging on that thing, that's where this becomes really fast. Because in MySQL, that's 2 queries. One of them is the actual query that gives me back the results that I wanted to show. Maybe it's paginated, maybe I only want 15 or 20 of them. But also then how many were there total if I hadn't limited it. And that's where you really can start to do advanced things with this. So let's do one more thing. Let's go ahead and put some pre-tags in here so I don't have to keep you sourcing on it. All right. So let's just look at a couple other things here. We can do, we can set limits. Sphinx has a kind of a query language in its own. It's called Sphinx QL. And so you can actually do some lightweight order bys in your queries. You can do some sub-selects in your queries. Sphinx QL is basically just SQL, but there's less words that you can use. So the limit, you can tell it's exactly like MySQL. There's a limit and an offset. So if I do this, we should get many more results back. Let's just do, yeah, you can see my page is way longer here. Great. So one of the other things I want to do is I want to show you how to add an order by to this. So we can add an attribute to Sphinx, which is not indexed, but it is used to sort the results. Because one of the things I like to do is I want to use their text engine to find things that are contextually relevant to what somebody typed into the search box. But I believe that I know better than Sphinx which things sell, right? I know which ones will sell better. If somebody's looking for XYZ offers, I know which offers are better. I can put them at the top of the list. And I have an internal sort that I can use for that, and I can tell Sphinx about it, and then they can use that to order our results with. So I'm going to go ahead. That happens to be called score. And it happens to be a float. So I can say SQL, right? So this is an attribute because I want to use it, but I don't care about what the values are as far as indexing goes. Go reindex. So this, by the way, is it's about 100,000 rows of data. Each row has, the name field of the offer is probably like a varchar 255, and the company name is probably also a varchar 255.
Is the row count in there like total 102,833?
Yes, that is approximately 100 rows. I think I've got some other stuff in there as well, but yeah. So it's you can see that generated, it pulled in 5.8 megs of data, and we can go look and see how big. Let's see. It took 13 megs on disk to index that. So there is an overhead cost for that, and this is where you want to be careful tuning, especially if you're in development and you're just kind of like adding stuff to it and see what works and see what doesn't work. When you find out what works, get rid of the stuff that didn't work so that you don't end up indexing it and like, oh, by the way, now that partition on your web server is full because the indexer just keeps piling crap on over and over and over again. So we got this, we re-indexed. So now we should be able to do Sphinx client. I think it's set order by. So, So you can see the order by sort mode looks a little bit like SQL as well. You can tell it ask or desk based just like you would with a SQL query. this guy is a constant. There's a couple different sort ones here. Generally, the sort extended will work for pretty much anything. You can get into it a little bit better, but we just end up leaving it like this unless there's a problem and it's not working the way we want it. So, if we come over, so we can see that now we've got this thing, and if we look at the score attribute here, it is going descending. And those, now because I added an attribute, not only can I sort by it, but I also get it back as part of my results. So let's do one more thing and then we'll call it a night. I want to add a filter. So right now I'm doing a plain text search, which is basically just looking for the word laptops inside these offer names and company names. Let's just try other searches. And you can see this literally comes back in no time at all. You can see the time is essentially not worth measuring. So we've got this. We need to go add some more stuff. So one of the things that you might end up doing is turning things that are not Boolean values into Boolean values, which is what I'm going to do right now. I'm going to select, these offers have coupon codes, and I'm going to just, I don't care what the code is necessarily. What I really care about is if it has one or not. So I'm going to basically write some SQL that will cast that into a 1 or a 0. So we can do something like if coupon offers coupon code is not null 1 0 as has code, right? So now I've taken something that's actually a varchar 32 and turned it into a Boolean value that we can use when we index content. And for good measure, I will go ahead and add the actual code itself. And we have to go tell Sphinx about these. So we can say, so I made code and a field string just because you never know. Some people, like maybe Dell has a coupon code called like laptops 15 that gets you 15% off laptops. And we want to pull that into, why not? It surely couldn't hurt. So let's see if we can go run this indexer again. Yes, all good. You can see doing that has added some more overhead to my data because I've added more fields, I've added more attributes. We can come in here and we've now got has code 0, has code 1. This actually has a coupon code. This one has one, doesn't. Everything's looking good so far. So now, if we actually want to do something like I was showing you on that category page on offers.com, where there's checkboxes in addition to a search box, so we want to refine our search a little bit, that's actually really easy to do. So we can go Sphinx clients. I will confess that I am cannot remember the API for this off the top of my head, but I believe it's that filter. So the one thing to note about this method is that it does expect an array because you can filter on multiple values. So this is 1 or 0. If you had a value that had like 7 different values, you could filter on like 1 and 3 in a range from 1 to 10, and it will just pick out the 1s and the 3s. But this particular method requires an array, so I'm just throwing that one in an array. Let's see if I remember that correctly. I have not. Is that filter? Yeah. So now you can see that all of my results that came back have a code, and they match glasses. If you guys missed that, I changed the searching for glasses instead of laptops. So I could add lots of different attributes from different columns in my database and very easily just add those additional filters on top of that and throw a full text search on top of that. And it still comes back in what I would say is not worth talking about time-wise. We implemented this functionality in MySQL with PHP and SQL generation and lots of stuff, and the page took about 45 seconds to run on 1 million rows of data if you added a bunch of filters. And then, one filter was fine, it came back in less than a second, but you start adding a bunch of filters and to go get all the counts for all the possible combinations and do the thing where you say, hey, that combination is not valid, so don't let them click on links to that, whereas this literally comes back, I want to say in production, this comes back in like 100 milliseconds for really complex queries. And with no real tuning. I mean, the Sphinx config file I'm using here is basically what we use in production. So that's just kind of a taste of what you can do with this. Obviously, I don't need to tell you guys how to go for each this and make it into something pretty that spits out HTML. But it's just an array of information that comes back. And that's where the real power of this lies, is doing the filtering and the sorting and the limit and the full text searching all in one step. You can also ask Sphinx to run multiple of these queries at the same time, and it does really smart things as far as keeping the right things pre-cached in memory for you and that kind of stuff. So you can send like 20 queries to the server at once if you need to test a lot of things and then use the results. They all come back in similar format to that, but they're in a big outer array of results that goes back. So that's all I have for tonight. I just kind of wanted to get you guys interested in it. There's a billion tutorials out there on this, but the documentation on sphinxstarts.com is really good. It's a good place to start, and and this has been a lifesaver for us as far as performance and our ability to actually build these features as opposed to not. So that's it. Thanks for listening. If you guys have any questions, I will do my best to answer them.
How about typos and things like that when you query?
Say again?
Like for example, typos when you query, how do you handle those?
So, yes and no, I guess is the answer. The stemmer does a lot of that morphology setting that I mentioned where it's stemming the words. If it's not too terribly flubbed, the stemmer can help with that. Because it's going to cut off a lot of the end of the word anyway and bring it down to its root word. So if it can do that, you're okay. On the other hand, if you just totally mangle something, it's going to run the search and it may come back with things you had never thought of. Because it can't do too much to correct typos beyond stemming. Usually you'd want to try and do that kind of in PHP, where you would execute this search, and if it came back with no results, in my case, I'd be surprised if it came back with no results. So then maybe I want to do it again, maybe look at that, maybe try and pass it through a spell or something like that and see if we believe it's a typo, and then we can kind of refine the search a little bit to help that. But Sphinx internals aren't great at that.
Can you do term vectoring? Like if you want to say, I want to relate contacts to glasses, so that everyone search for glasses and also get contacts results?
A little bit, yes. You can use the boosting and weighting a little bit to do that. If you need to do that, Solar is way better at it. Cool, thanks guys.